Do you see my whiteboard or no? Answer me, yes or no?
Yep.
Okay, cool. Okay, just I remember we are doing 19 now 20 problem. Okay, basically, okay, good. Apolinario Andrés. The thing we are doing is factorization. Pero factorization trinomial, no? How do you know que trinomial? 1, 2, 3, no? 3 terms. In this case, it's similar, except the new thing that bring me this example is we have two variables. In this case, u and b. But it's the same. You open two parentheses. Look. You put the name of the first variable, okay, u, and you try to find the combination that open the door. The combination that open the door, I guess so, is 28. Is 7 times 4. So 7 times 4 is 28. And 7 minus 43. Get the middle term. So 7 minus 43. So this is the combination that open the door. This trinomial. If you copy 7 and 4, it doesn't matter. You put in the first place or in the second place. But you adjust the sign. And the sign is, remember, when this sign is negative, we expect different sign. And when this sign is negative, this negative is the sign of the bigger number gets negative and the other is positive. Just in case, to make sure our answer is okay, you FOIL. U times u squared. U times 4 is 4u, positive. And minus 7 times is minus 7u. And minus 7 and positive 4 is negative 28. And when you combine like term here is minus 3. I forgot the most important part.
Professor and B, what happened with B?
What happened with B? She said, be here and be here. So be here and be here and be square here. And it says minus 3 UB. She said, what happened with B? I forgot the B. Okay, to say UB. If the middle term is the same, nice. This is the answer, the factorization. Que corresponde with the option. Let me see what option, 7, negative, and positive 4. I suppose que C, no? Okay. Okay. Everyone follow me? It's okay?
Yes.
21. 21. 21. 21 is u squared minus 4ub minus 45 b squared. Okay, you open two parentheses again. Put the name of the first variable, okay, u. And the complicated part is find the combination, no? Okay, open the door. In this case, 45 is 9 and 5. 9 times 5 is 45 and 9 minus 5 is 4. And our combination is 9 and 5. 9 and 5. But in this case, I don't forget the b. And you put now, in this moment, you put the name of the second variable, okay, b. Now what about the sign? This sign is negative, we expect different sign. This sign is always the sign of the bigger number gets negative, and the other is different. Boom. Multiplication to verification. This is, in my opinion, is mandatory, but not strictly mandatory. No? So you want to, so you are sure this answer is correct. Not necessarily check it, but sometimes it's good. So says u squared plus 5ub minus 9ub in alphabetic order, in the same order, minus 45b squared. You combine this and this together is minus 4ub. Exactly. This is the answer que corresponde with the option. Let me try. Option A. Thank you, sir. Yeah. Wow. The next is a little bit complicated because the number is too big. So sometimes it's weird. Okay, let me try. Let me try to do my best. 20 second. 20 second is x squared plus ax y minus 128 y squared. So this is complicated because 128 is a big number. But maybe 16 times 8. Let me try with my calculator. In my calculator, I multiplication 16 times 8. Oh yes, it's 128. And subtracting 16 minus 8 or addition, depending on, in this case, subtracting is 8. Okay, this is the combination. Open the door, you open two parentheses, you put x gets the first variable, you put the number gets 16 and 8. Don't forget the second variable gets y, and you adjust the sign. Different sign, 16 positive and 8 negative. Remember, this sign is always the sign of the bigger number. And this sign indicates it's different or the same. In this case, different because it's minus, so it's plus. See, this guy is plus, another is minus. The second part is x squared minus axy, FOIL, plus 16xy minus the big number 128 y squared. And when you combine this and this, it's obvious it's a positive xy. Is it the answer? And the solution is A. Cool. Everyone follow? You remember very well this in high school or no? Now let me see. Say yes. Very troncoso. Okay, cool. So now let's move on to, well, we continue trinomial. But remember, we have three kinds. So in my mind, I need to classification trinomial in three. The first thing that we studied was the easy. And the easy is when there's x squared plus, you know, something, px plus q. This is easy. However, when you have coefficients here, for example, you have ax squared plus px plus q. When this coefficient is no one, here is one, easy, nice, I like that. It's complicated. I call in my language complicated and easy. In the book, no, in the book called x squared plus px plus q, is a classification of the first kind of trinomial, and the second is ax squared plus px plus q. Okay, so let me explain because the factorization is a little bit different. Pay attention. There are two methods, and what is the best depending on the problem. However, I want to explain both. Suppose 23. 23 is 12 x squared plus 17, no? 17, yeah. 17x plus 6. Immediately you realize that this is trinomial complicated. And the reason it's complicated is because this 12. See, we have now this 12. It's easy. So there are one method that is, the name is the like a factorization by grouping. What is the strategy? The strategy is you convert temporarily, of course, the trinomial and polynomial. So you convert trinomial gets 1, 2, 3, 3 terms, and 4. Using, of course, the smart way. So you multiplication this guy and this guy. It doesn't matter the sign. The sign is not important. You take the number, multiplication of each other is 72. And you analyze carefully, of course, the factor of 72. Que somehow, when you adding or subtracting, give me 17. So I detecting, maybe I spend more time on the students are doing fast, que es 9 times 8. So 9 times 8 is 72, and 9 plus 8 is 17. Cool? Okay, now this is the most important moment. The most important moment is you bring down 12x squared. You bring down this 6. So you bring down the first and the last. And you split 17 using 9 and x, like that, plus 9x plus ax 6. So you convert trinomial, look at that, trinomial. Now in polynomial, quarter. I know very well that the polynomial, the factorization by grouping. So we have the couple green, the couple red, sorry, and the couple green. And you find the GCF separately. So the GCF in the first couple and the couple red is 3x. Because the great common factor between 12 and 9 obviously is 3 and 1x. And open new parenthesis, so we have 4x 3. Likewise, the great common factor between a and 6 is 2, just 2, no x, and we have 4x plus 3. Entonces I am super happy because 4x plus 3 is a common factor again, so this factor is exactly the same of this. See, we don't get that to say it's because the combination, what is the 4? Okay. Mister, what 4 you are talking about? For example, this. In my mind, this 12 is 3 times 4. And this 8 is 2 times 4. So I factor out this 3. That is a reason that this 4 is this 4. I don't know if it's your question or not. And when you factor out these two go out, stay that 4, get this. Makes sense now? Yes, I got it, okay. Okay, then. The thing I tried to explain was, like detecting, can we obtain new binomial that is 4x plus 3, nice. Yeah, the same, so you factor out one more time. Open last parenthesis, I promise, because the last. So now inside the last parenthesis, we have 3x, this 3x. And 2. Just this. It's a plus, sorry. And it's my final answer. It's my final answer. Of course, we need to verification always to make sure okay, everything is okay or no. And you FOIL. FOIL is a classical method that we use to multiplication to binomial. You FOIL. A multiplication of 4x times 3x obviously is 12x squared. Outer is ax. Inner is 9. And last is 6. And when you combine these together, it's 70. Exactly like the original. This is one way. So I recommend, my recommendation, my experience, say that this method is good. It's good when you multiply. Look, this is the central idea. You multiply this and this, and you get the acceptable number. What means acceptable? Que es, less than 100. Because C is greater than 100, this is very, very complicated. They are another alternative method que some students like. Person I don't like too much. I apply when it's strictly necessary. Remember, we are studying complicated trinomial, no? Don't say, oh, too much. Not too much. It's complicated. It's the most complicated. The other is super easy. In which you take, this is the grouping, no? Grouping method. In my opinion, 99% of the time you apply this. However, another no. How do you know? When you multiply this number times this number, see you, the answer here is 100, 120, 150, 200. So it's too complicated doing this way. So there are another way que es try and error. Try and error. Que as its name indicates is like a guessing. Try and error. What is the idea behind try and error? Well, you take the original trinomial, look at that. You have no idea. You are totally lost. No multiplication, because when you multiply, give me a horrible number, not good. Now, you, for example, you take the first guy, important, 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 and the second guy, important, important, important. And you copy here the potential factorization for this monomial, no? Okay, obviously is 12x times 1x is a one possibility. And another possibility is 6 and 2, maybe. 6 and 2. And 4 and 3. This is the possibility of the factorization, the first. And 6. Well, 6 is 6 times 1. This is 6 have no x. So x no participate in the game. And 3 times 2. And you form a totally crazy, totally randomly different combination. So es too consuming time. This is a disadvantage of the try and error. Because actually we have 1, 2, 3, and 3, and here we have 2, so we have 6 combination. Yeah, I try to verify. Of course, I know what is the combination because I did before using another method, and I know that the combination is 4 and 3 and 3 and 2. Okay. Suppose que I am looking, then I select this combination. So I write this combination, but I write in two different ways. Copy 4x, 3x, 4x, 3x. Oh, look like similar, right? But you copy 3, 2, like that. And 2, 3. It's the only. So you switching the second. Entonces, obviously, the sign is elementary because everything is positive because this trinomial, everything is positive, 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 positive. And you now quickly are doing the FOIL, but not completely FOIL. You are doing the multiplication first, outer, inner, last. No, you are doing outer, inner, because first and last would be the same. Then you multiply outer, get this is 8x, and this is 9. And you multiply here is 12, and this is 6. But I need 17, remember, in the problem. Then you adding or subtracting ax plus 9x, oh, it's 17. Entonces I got it, and the combination, the word is this. And the other no, because it's 12 and 6. Well, addition or subtraction, no? Si you're subtracting is 9x minus ax, no good. It's 1x. Here, never, because it's 12x plus 6x, que es 18. And the other combination is 12x minus 6x is 6x. But I need 17, because the only combination que guarantee this is I know it's too hard. My recommendation is avoid try and error 1% of the problem we are doing. I need to explain. And 99% we are doing using grouping. Cool? Do you understand a little bit? Let's practice now, eh? This, in my opinion, is the most complicated part. The rest is easy. The rest is easy. Okay. Okay, let's practice another problem. Cool. Okay. Let's move on to the question. So the answer for the number 23 was C, no? Was C. Okay, now let's do it now. 24. 24 is 6y squared plus 13y plus 6. Okay, cool. Me, I see, wow, it's a complicated trinomial. I don't like this, but I need to do a multiplication. 6 times 6, 36. Oh, 36 is a no big deal. It's acceptable number. Yeah, I try to find the combination that open the door. The combination that open the door is obvious because 9 times 4. Because I know that 9 times 4 is 36 and 9 plus 4 is 13. And this allow me bring down this monomial, and separate 13 using 9 and 4. Of course, with the corresponding variable, no? It's 9y and 4y plus 6. Do you understand the idea? It's obvious if you combine line term in between 9 and 4, we come back at the beginning. Pero no, it's not the intention. The intention is the conversion between trinomial original guess given and polynomial for term. Now I am ready to apply factorization by grouping. Grouping. The red couple and the green couple, as always. What is the GCF in the first couple? Well, a 3y. So it's 2y plus 3, I guess so. I suppose que everyone follow me, no? GCF. And the second is 2. So we have 2y plus 3. I am super happy because I get 2y plus 3 repeated. 2y plus 3 is a common factor. Open the last parenthesis. Inside the last, we have 3y plus 2. Boom. Final answer. Also, beautiful. It's 2y plus 3, 3y plus 2, like the option D. Do you follow me? Do you understand very well or no? Or very confusing?
It's a little confusing for me.
What part?
The last part, like, how do you get this 3y at the end in the last parenthesis?
Oh, okay, cool. You see, miss? Okay, we have here 2y plus 3 and 2y plus 3. It's exactly the same we explained in the last class, the factorization by grouping. Entonces now, that is the reason que allow me factor out 2y plus 3. Entonces, when you, this gets 2, you factor out like only one outside, stay here, look, this 3y is this 3y. And this is 2 is this. Of course, with the corresponding sign get plus. Make sense? Do you see or no?
Yeah, I got it.
Okay, so we continue. Come on. I get confused with the last part. However, Karen, do you understand now or not yet? Karen, because you typing something in the chat. Not yet. Okay. Don't worry, be happy. I suppose that you understand so far that part. Yes or no? That part is clear for you? Excellent. Now, the easy part, Karen. You separate, it's a grouping. And grouping is two couple. The couple red and the couple green. Es obvio que the GCF and the couple red is 3Y. Do you see or no? Let me know if you see. Yes, because I factor out this 3Y. When I factor out this 3Y, I open new parenthesis. And inside the new parenthesis stay 2Y plus 3. Why? Because in my mind, 6, I consider like a 3 and 2. And y squared is y times y. Entonces, you factor out 3y, stay 2y, que es this. And here is 933, no? And then you factor out 3y, you factor out 3, and this y stay only 1, 3. Okay, this 3 is this 3. Make sense? This is the part that you don't understand. Karen. Okay. Likewise, this 4 is to 2, and this 6 is to 3. So I discover, wow, fantastic. 2 is a common factor. I factor out and stay 2y plus 1, 3. Get this. Okay, beautiful. Now we continue. We continue practice that part, gets a complicated part. And I have another page here. Okay, let me try. Okay, 25, say 9z squared minus 6z minus 8. Well, in this case, the first thing, you understand it's a complicated trinomial, yes or no? When the coefficient in front of the quadratic is no 1, it's obvious that we are in front the complicated factorization. But don't worry, be happy. And now you multiply. You multiply who? Multiply 9 times 8. But I don't care the sign, 72. So you take the absolute value. No, the sign is not important. No, it's positive, it's negative. No, it's confusing and create noise. No, it's 72. So one combination, let me try. This is 6 and 12. 6 and 12 maybe. You investigate. This is the part that maybe it's a little bit consuming time, but you have calculated. You take from 72, you investigate get 12 times 6 is 72, and 12 minus 6 is 6. So the thing I investigate, and maybe some students spend more time, I don't know, is 72 is the multiplication 12 times 6, and 12 minus 6 is 6. And this is the number that we have in our trinomial, 72 and 6. Okay? And the easy no, because when the easy is 1 here, so basically is this and this. Because there's a coincidence that the multiplication is this number. Okay, now ready. Bring down 9c squared, bring down 8 negative. And separate 12 and 6 like a 6. This is minus, be careful with the sign, 12c plus 6c. Okay, why this sign? Oh, because I have verification, when you combine like term, minus 12 positive 6 subtraction, and put the sign of the bigger number get negative. Wow. So we come back at the beginning. Pero no. Never I doing this. It's just to verification mentally. Now I am ready to apply factorization by grouping. Now ready. The GCF is 3Z. In between this GCF between 9C squared, comma 12Z. You agree with me? It's 3Z.
Yes.
Excellent. Likewise, GCF between 6Z and 8, I suppose que 2. 8 have no C. Pero A in my mind is like a 2 and 4. And 6 is 2 and 3. Entonces 2. I factor out in the red couple. I factor out 3C. Entonces stay inside the parenthesis 3C minus 4. Close. And the green couple, the gray common factor is 2. Factor out 2 and we have 3Z minus 4. You are doing well, guys. Surprise, you see that this binomial is exactly the same as this. And this is the beauty part. When I take that, I get that to say I am almost finished. Because I factorization 3C minus 4. Open last parenthesis inside the last I copy 3Z. Is this. That is the final answer. Out. Okay, corresponding 3C plus 4 minus 4, 3C plus 2. 3C, is this one. Remember, the order of the factor is totally irrelevant. It's the same answer. So you permutation, if you switching the factor because it's a factorization. And factorization means multiplication, and the multiplication, you know, is completely independent of the order. Okay. Let's move on to the next. Any question? Any question? Do you follow me? This is complicated. I know. Sorry.
Sure.
Uh-huh.
You put C or B in the answer.
Let me see. You are right, B, no?
B, right?
Yeah, you're right. Thank you. B because it's 3C plus 2, is this? See, I am not good. I am doing well. No, not always. I'm making mistakes sometimes. But I am doing well. However, I select wrong. I suppose guess because I don't pay attention this because I passed this class, no? But no, you don't. So you need to pay attention. Option you select. Okay, let me try number 26. Okay, there you go. 26. Okay, let's do it step by step. Slow down because I need to understand this part is a little bit long and complicated. But it's important, guys. It's important because we use it anytime in the algebra. Okay, 15z squared. 15c squared minus 4z minus 4. Okay, I realize it is is complicated, right? And so you multiply 15 times 4. I don't care the sign. It's 16. Okay, so what is the combination that open the door? The combination that open the door is maybe 6 And 10, no? Ooh, I like this. 10 times 6 is 60. Okay, I copy here in the corner. Multiplication 10 times 6 is 60. However, you need to condition, no? Is 10 minus 6 is 4. Okay. I get that number. I get that number. It's this 4. The sign is not important. Okay, do you understand this idea? This is consuming time, maybe. I want to, I am saving time because depending on the intuition of the students or the person, you get the combination faster or no, depending on the intuition. Now, bring down 15c squared, bring down minus 4, and you split 4 using 10 and 6. Be careful with the sign. It's minus 10z plus 6z. Why? Because I put intentionally negative 10 and positive 6, because when you combine like the subtraction, obviously it's 4, but negative 4 is the sign of the bigger. Cool? This is the, in my opinion, is the central idea, because the rest is piece okay. The rest is grouping. The red couple and the green couple. What is the GCF on the first couple? I suppose que 5Z.
Wait, excuse me, Professor, can you repeat why the 10 is negative?
Because, let me erase everything. This is an important question. When you verify quickly, we combine like here, in the second and the third term. It's obvious that negative 10 and positive 6 subtraction is 4, and you put the sign of the bigger number. Because the idea is obtain exactly like this. Look, because this expression and this expression are perfectly equivalent. The only thing is that you create artificially 1, 2, 3 trinomial and 1, 2, 3, 4. Entonces now when the polynomial for term, we'll be ready to apply grouping, factorization by group. Cool? Yes or no? Do you understand very well?
Thank you. Yes.
Now yes. Ready. This is the complicated part. And now, grouping. We focus. The red part, the green part. The GCF and the red part is obvious 5z. So we have 3z minus 2, no? Okay. And the GCF and the green part is the 2. 3z minus 2. Okay. One more time, happy. This expression is equal to this expression out factorado. 3z minus 2. Open last parenthesis. Inside the last parenthesis, we have 5z. Boom. Entonces you help me as always to select the right answer, guys. Suppose que es this, yes or no? Any question? Okay. Let's do it next, because next look like horrible. Have a question? Suppose to multiply, and you supposed to multiply. Yeah. You are right, miss. So she said, okay, I suppose verification. Yes. I am doing too fast. It's not good. So this answer, to make sure 100% that we are doing well, you for this is checking. Doing quickly is 15c squared. So 3c times 5c, 3c times 2 is 6. This is minus 10, and this is minus 4. When you combine this and this together, it's minus 4c, exactly like the original. Checking. Yes. Okay. I strong recommend checking, please. Okay. Okay. Let's move on to next. Next is 27. Look like horrible. Because, okay, this is a classical example in which okay. Wow. Okay. Look, this is 5m squared plus 39m plus 54. Wow. When you multiply 5 times 54, 54 times 5, I'm doing now in the calculator, that's 207. And this indicates also que the method that we are doing of the factorization by grouping is not good in this example. Not good. Entonces I erase this. I try to the horrible. To 70. Yeah, maybe, but no. So, in my opinion, no. Don't. When you see the multiplication give me more than 100, entonces doing in the other way is too complicated because we have a lot of combination, and you spend a lot of time analyze every combination. Entonces, my recommendation is that you apply try and error. And try and error is not too hard in this problem because I take advantage. Okay, you take the first and you take the last. Temporarily, you forgot the middle. 5m squared, the only combination is 5m times 1m because 5 is prime number. So I take advantage, nice. However, 54, no. 54 have a lot of combination. 54 is, well, 54 and 1, suppose it doesn't work. 54 is even, is 27. Uh, 27 times 2 is 54. 54 is also divided by 3, 18. Not by 5, by 6, yes, is 9 and 6, 54. So I try, we have, wow, too much combination. We have 1, 2, 3, 4, and 1 is 4 combination. I know. I try to select the combination that you consider elementary. Remember, you copy 2 times the parentheses because we have 2 combinations. Suppose I take this. No, it's the only one I have here. But I take this. Okay, I verify. If it doesn't work, to say I need another A. I cross this. So it's 5m, 1m, 5m. You see I copied exactly the same, but I switching now 96 69. Okay. Try and error, guys. This is try and error. How do you know that try and error is the best way? Because this number, when you multiply, give me a huge number. Greater than 100. And now multiplication, pero multiplication especial. Multiplication like that, and multiplication like that. This is 5 times 6 is 30. 30 what? 30m. And 9 times 8 is 9m. Oh, I like that. Because 30m plus 9m is exactly 39m, que es the number que I need. Okay, you want verification the second option, but I suppose, well, no. Let me try. This is 45. And this is 6. No, not good. Because 45 plus 6 is 51. Not good. This is not good. This is the combination of the word. It's obvious in this problem, both signs are positive because everything is positive in the trinomial. That's my final answer is 5m plus 9. And m plus 6. And now FOIL to verification. This is 5m squared. This is 30. And I did that. This is 9. And this is 54. And this together is 39m. This is a repetition the same. And this is the answer. No big deal. Suppose that when you select this combination doesn't work. So you cross this and you try another. You put 18.3 verification. But no, I did the first one because I know the answer. If you don't know, entonces you are in big trouble. So what's the answer? The answer is 5m plus 6 plus 9. Is that one, no? It's the A. You correct me, say make a mistake. It's a little bit complicated, right? I don't like this. I suppose in the test I put only one example of this. Okay, everyone follow me on lost. You are lost? Come on, guy, answer me.
No.
No, okay.
I just wonder what happened if we do 30 plus 9. I mean, 30 times 9 instead of this trial and error. And we do the other option doing like 30 times 9, which is equal to 70.
And what part? In that part, you say?
No, like this is a method, trial and error. But how about if we do the other method, doing like 30 times 9?
The other method is crazy because remember, I multiplication 5 times 54, no? I did before, no? And the answer was
270.
270. Okay. You're right, 270.
Which is equal to 30 times 9.
Entonces, what is the factor que somehow give me this? So it's 30 and oh yes, look, it's okay. 270 is 30 times 9, no? And 30 plus 9 is 39. Okay, entonces do you think it's better for you to see that?
Yeah, I just wonder if we can do that method instead of this one
maybe,
also.
Okay, I agree. However, maybe it's easy when you get the final answer. However, if you want to investigate the factor of 270, 270 times 1, 270 divided by 2 is 135. So at the beginning, you don't know. Time to, you know, and you bam, divided by 3, divided by 4, divided by 5, divided by 6, until you get the combination que open the door, que es 30 times 9. Do you see the disadvantage of this way? Okay. Don't frustrate. Because we have two methods. So to have two methods is good or is bad? It's good because you have two options. So my recommendation is, well, you frequently, 99% of the time, you apply the famous grouping method. However, we have another option que es try and error, que in my opinion is better when the number, when you multiply, is bigger, pero bigger down something, 100, 200. Okay, so either way, the way you prefer, you get the same answer and you check it and you get right answer, no problem. Okay?
Okay, thank you.
Okay, so now I change a little bit. And you need to be aware for that situation. Look at that. This is completely new. Pay attention. Okay, this guy, I want to take advantage. So trinomial factorization is a complicated part. Trinomial is very complicated. We have three kinds of trinomial. The first is easy. What is easy? X squared plus px plus q. And the factor here is 1. Complicated is ax squared plus px plus q. The a is no one. You know, multiplication, grouping, or try and error, whatever. Now I have another that we want to study, que es perfect square. I don't know why the student forgot perfect square. And perfect square is easy, super easy, and super useful. What is the idea behind perfect square trinomial? Suppose two scenarios. Suppose x squared plus 4x plus 4. X squared minus 10x plus 25. You say, bueno, professor, pero this is the easy trinomial. Because I saw that the coefficient is 1. Yes, you can categorize like easy. Because I don't know very well, I never see before square. But I want to illustrate that they are both. Also, I have no idea. I open two parentheses. I put the name of the verb, que es x. And the combination is 2 and 2, because 2 times 2 is 4, and 2 plus 2 is 4. It's a coincidence, plus. And when this situation happens, when the factor is the same, twin brothers, you can write like that. And so when this situation happens, when they are twin brothers, and you condense in only one factor, this is perfect square. Okay? This example, for example, this is perfect square because the combination is 5 and 5. 5 times 5 is 25, if 5 plus 5 is 10. The factorization is x minus 5. Be careful with the sign because this sign is negative square. Do you understand the idea behind perfect square? Es especial because the factorization is, you know, the regular scenario is que you have two different binomials. But in this case, no, it's the same. Si es the same, wrong, you put together. Ahora, what are the tests? What are the tests que I can apply to verify si es perfect square or no? Because this example I put here is too easy, elementary, but sometimes no. When you are doing next, you see it horrible. So there are one special test to verify if my trinomial is perfect square or no. Okay, so now what's the test? One of the tests, I have no idea. Suppose I have no idea. You take the square root of this, okay, is x, and you take the square root of this. Get 2. And you multiply each other. 2 times x times extra 2. Always 2. This is extra. Yeah, I want to explain why. Pero no now. Then you get 4x. Yeah, this is exactly the same of the middle term. Wow! We can affirm that this trinomial is perfect square. Let's do in this. Square root this is x. Square root this is 5. And 5 times x times extra 2 is 10. Doesn't matter the sign. The sign is not important. This is perfect square. Perfect square triangle. Do you see or no? Maybe the question will fly in the air. Why extra 2, professor? It's easy to explain. Look, let me show you. The classical perfect square format is a plus b squared. It's the same factor as a plus b times itself, twin brother. If you foil this expression, a times a is a squared. A times b is ab. B times a is ab, so I put in alphabetic order, and b squared. When you combine like term here, you have a squared plus 2 times ab squared. This is the reason of the extra 2. But the test to verify the one trinomial perfect square is you find the square root this guy. You find the square root this guy. So the first and the last. Multiply each other and multiply by extra 2. See, the answer is exactly the same, the middle term. Wow, it's perfect square. And when this situation happens, the factorization is too easy. Too easy, too easy, too easy. Too easy. Let me finish doing the next example to illustrate very, very well this idea. Is, 81 x squared minus 126x plus 49. Frequently happen. It's a funny guy. The student says, what the hell is that? A multiplication. 81 and 49. Let me try and my calculator. 81 times 49. Wow, it's a big number. 3,969. This is crazy. Doing it that way. It's possible. Of course it's possible. But it's crazy. Entonces, you need to, what is the clue to give me information? This is wrong answer. Wrong, not wrong. This is complicated way. I need to dedicate 1 second, only 1 second, to testing see this trinomial is perfect square or not. And what is the clue? It may be it's perfect square. Because that number and that number is perfect square. I know that square root 81 is 9. And the square root of 49 is 7. Entonces, square root this is 9x and the square root this is 7. And you multiply 9x times 7 times extra 2. And this is 9 times 7 is 63 times 2 is 126x, gets exactly the same of this. The confirmation is, wow, this trinomial that we are working in this example is perfect square trinomial. Okay, I classify, but I don't do the factorization. But the factorization is too easy. The factorization is just taking this and this together. 9x and 7 is square because it's perfect square. And you put a sign of this, the first sign. Boom, final answer. Do you understand very well?
Yes.
Yes.
You need to be aware for that situation. You see, wow, it's too hard. No, it's not too hard because the classification is perfect square. So now is 9x plus 7 minus, no, minus. The answer is this. Because it's perfect square. I promise that we practice a lot of perfect square in the next topic. This was a coincidence that you see this example, but it was good to explain this idea. Okay? Perfect square. Be careful. What kind? How many classification we have of the trinomial? 3. The first one is easy, the second is complicated, and the third one is perfect square. And you need to be aware. So you are the student, I don't know why I forgot perfect square. However, perfect square is easy. Let's do 29. 29 is 4x squared minus 9x plus 3. Oh, this is perfect square. No, this is no perfect square because 3 is not 4. Yes, square root 4 is 2. For the square root 3 is, you know, it's a decimal. Put in the calculator. No, it's not perfect square number. So don't expect that this trinomial is perfect square trinomial. No. The first requirement is both number and the first and the last must be perfect square. And after verification, your multiplication by extra 2, and you get the middle term. Nice. But in this case, no. So this is classical complicated. And you multiply. You multiply. 4 and 3 is 12. Yeah, I try to investigate the factor of 12 somehow give me 9. Okay, let me try to do my best. My best is 12 is 12 times 1. But 12 is also 6 and 2. And 12 is also 3 and 4. Let me copy here. That way. 4 and 3. Doesn't matter. The order is not important. But I want to 1, 2, 3. And by 4 is a coincidence. By 5, no. By 6, I did. This is the factor of 12. Yeah, I need to verification is this factor and somehow give me 9. When you're adding is 13. When you're subtracting is 11. No. When you're adding is 8. When you're subtracting is 4. When you're adding is 7. When you're subtracting is 1. Never you get 9. Therefore, the conclusion is this trinomial is prime. Because it's impossible to find the combination that open the door. And the answer is prime. Okay? I suppose in the test I never put this example. The prime means it's impossible factorization. But when I try to illustrate in the lectures, this possibility, no? Prime means, suppose I want to break it down, 17, no? 17 is a prime number, so 17 is just 17. Now 16, no, 16 is 9, divided by 2 is 8, divided by 2. 2, oh, so 16 is 1, 2, 3, 4. 1, 2, 3, 4. A composite number is 2 to the 4th power. But 17 is just 17. 17 is prime. Exactly like this trinomial. It's impossible to break it down binomial. This idea is clear? Yes or no? Now let's practice now perfect square. I have 1, 2, 3, 4 examples of the perfect square. I guess so. The first one is okay. It said you said the questions say verification if this trinomial is perfect square or no, and factorization. You see, one professor, but actually is also easy trinomial, no? Yeah, you're right. You're right. The answer is 10, no? Because 10 times 10 is 100. And 10 plus 10 is 20. Good, I like that. However, I want to verification using the test of perfect square. What is the test of perfect square? You take square root this guy, is x. You take square root this guy, square root 110, multiply both x times 10 times extra 2 is 20x. It's exactly the same as this. So the conclusion is, wow, it is perfect square trinomial. See, it is a perfect square trinomial. The factorization is not two parentheses, it's only one. Because they are twin brother and a square. And the factor is x and 10. And what sign? A plus. Boom, final answer. Like this. Excellent. You follow me? Because the idea in this example is, well, either way, you can treat, yeah, you can, you know, manipulate like a easy trinomial. Okay. So you say, no, I don't like that part. Okay, I ain't doing different. I ain't doing like that. Okay. You open two parentheses. Put the x, que es the variable, and you find the combination que open the door, que es 10, 10. 10 times 10 is 100, and 10 plus 10 is 20, plus. And this answer is equivalent to this. Either way, you can write separate in two, but they are the more elegant answer. This is aesthetic, not only. This is two answers are algebraically equivalent 100%. However, more clear is when you have the same, you put together and put a square, right? But it's okay, either way. This is the beauty of the Mathematica, right? Mathematica, you have different answers and they are good if they are equivalent algebraically. Okay. This is frustrating, for example, when you take calculus, you spend 30 minutes doing one problem. So when you obtain the answer, okay, by the way, it's good, you're doing well. You go, for example, the back of the book or the handout is given for the teacher. You see, wow, it's different answer like me. Yeah, I suppose que I'm doing well. Oh, the problem is slow down. You are doing well. This answer, your answer, and the answer you put the teacher is equivalent algebraically. It's the same. It's the same. And you need to be aware that this situation frequently happens. Okay. Next, x squared minus 16x plus 256. Okay, this smells a little bit like a perfect square. Why? Because square root this guy is x. And the square root this guy, I put in a calculator, of course, is, let me try. So I take my calculator, I put a square root. Okay, square root. What is the square root of my calculator? There you go. Square root 16. Oh, the square root 256, sorry. Ah, there you go. I found square root 56 is 16. Wow, nice. Now your multiplication, x times 16 times extra 2. Don't forget the extra 2 is super important. It's 32x. And in this case, no coincidence with this. So the answer is no perfect square. Okay? That was 31. 32 is b squared minus 34b plus 289. and they want that you verify it's perfect square or no. Okay, no problema. I try to do my best. Square root, square root, square root, square root, square root b squared is b, and square root of this is 17. Guy, you don't need to know by memory this. Square root 289 is 17. I put in my calculator, I get that. Now multiplication. Multiplication b, multiplication 17, and multiplication extra 2 is 34. It's exactly the same of this. So the conclusion is it is perfect square trinomial. In this case, the conclusion was it is not perfect square trinomial, and the factorization is super easy. Is you take b, you take 17, put together, and the sign is this. Minus. Is the option this one. Okay, the other option is wrong, totally wrong. It's b minus 17 squared. You follow me? Perfect square. Ooh, ooh.
Yes.
Okay. The complicated part of this chapter is that we need to integrate everything that this idea in your mind. Now, okay, don't worry too much for this, because in the review package, I want to dedicate to apply everything like a miscellaneous, no? Entonces, es super important classification. So our problem is trinomial, our problem is binomial, our problem is polynomial, our problem is trinomial, pero es perfect square, or no, es easy or complicated. So the classification is extremely important to face the technique. We have different tools in our table. I need to get the tool, the proper tool to help me to factorization this expression. Okay, entonces es important to say, bueno, si es trinomial technique, si es polynomial or binomial, whatever. Okay, one more of the perfect square. Yeah, I suppose that you understand very well, at least understand. No? This is my intention today, understand. After we practice more. And you need to practice by yourself using Alex, no? Alex homework. Okay, this look like good to be perfect square because the square root this guy m and the square root this guy 4 and multiplication each other m times 4 times extra 2 is am exactly like that. Now the confirmation, it is perfect square trinomial. Therefore, the factorization is m 4 and plus. And don't forget square. Easy, eh? Easy or no? Eric. Okay. Now, we for a moment don't working anymore for the trinomial. Let's working now binomial. Binomial, in my opinion, is easy because, well, you identification binomial two terms. So we have three kinds of binomial. We have, for example, the first formula that we need to remember is this: a squared minus b squared is equal a plus b, a minus b. What is the name of this case? This is differences of a square. Differences of squares. It's obvious, no? Because it's subtraction, no? It's different. Subtraction, difference is subtraction. And square is a square plus b. Be careful because this formula is applied not always when there's 2. In general, it's when there's even number. So maybe 4, maybe 6, maybe 8. When the exponent are even number, you can apply that formula. Maybe you need to apply it not only one time, you need to apply it several times, depending on the exponent. The second formula important is a cubic minus b cubic. Okay, what is the name? Well, it's the difference of cubic. And the difference of cubic is a little bit different. It's a minus b, a squared plus ab plus b squared. B squared, square, square, square. Okay. What is the name of this formula, guys? Differences, differences, differences of cubic. It's logical, no? Because it's 3. And not necessarily 3. It's any exact multiple of 3. Maybe 3, maybe 6, maybe 9 is considered like a difference of cubic, no? And you say, well, professor, okay, but I don't understand one thing. What is the reason? You have binomial here, but you have trinomial here. And what is the reason that you don't apply here factorization this trinomial and break it down in 2 parts? Oh, the reason is because always I guarantee you 100% this trinomial is prime. Okay? That is a reason that the formula is like that. Okay? I guarantee 100%. Any cases, can you break it down, the difference of cubic, we have binomial and we have trinomial. And this trinomial is prime and you don't touch anymore. Now number 3 is a sum of cubic. The sum of cubic is very similar as a minus b, a plus b, sorry, a plus. It's a plus plus. And here we have a squared minus ab plus b squared. This is the sum of cubic formula. And again, happening in this trinomial prime. One fantastic way, guys, to remember. Okay, you don't need to remember, no, because the test is at home. But in the real life, when the classes, when the lecture come back in person again, well, to say one way, one more divide to remember that formula, 2 and 3 together is you put a cubic plus and minus b cubic is a plus and minus b because it's the same size. It's minus minus a plus plus. And the trinomial no, and the trinomial is a squared minus plus reverse ab plus b squared. Conclusion. In the difference, in the trinomial, everything is positive. And the sum, the first sign is negative, the second no. And the binomial is the same sign, the minus minus plus plus. Either way. Some people say, no, I don't like this weird symbolic way. Okay, no problem, I respect. Cool. And that's it. That's it. So I don't understand something, professor. I don't understand the discrimination of the sum of a square. Because we study difference of cubic, sum of cubic, difference of a square. What is the reason why we don't study sum of a square? The reason is this expression is impossible factorization because it's prime. Okay? But you see, I suppose que never you see that. But in one problem, a stupid problem, put the factorization, this expression. And you see it's a square, but it's plus. Entonces, no, it's impossible to do that. Okay? This is the formulas you need to remember. Let's move on directly to the problems. Suppose the problem number 34. 34 is y squared minus 64. Ooh, it's a binomial. Look at that. Classification. How many terms? How many? How many? How many terms? Those terms, our expression, has. Es two. 1, 2. No es el binomial. And the binomial we use in that formulas. Si es trinomial, it's more complicated. Professor explained que you have easy, complicated, and perfect square. Pero no, in this case, super easy. Es binomial. And binomial classification is obvious different of a square because of subtraction and square root. Y square is y, and square root 64 is 8, no? And you copy two parentheses, exactly the formula say, and this is in my formula, the first guy is A and the second is B, but in our specific example, A is Y and B is 8, and plus and minus. Or minus plus, the order is not important. If you want to verification, but in this case, not necessary verification. This is always work 100%. In the trinomial, yes, it's because it's too complicated. But no, in this case, it's super, extremely easy. Pero bueno, let's do it at least one time in our life. You foil y squared minus y minus ay plus ay and minus 64. And all will happen is that part cancel out and stay alive y squared minus 64 exactly like the original. That this expression both are perfectly equivalent algebraically. But don't do that. I did. Do you follow me? Do you follow me?
Yes.
Verify now. Verify say y squared minus u squared. Wow, this is easy. Again, one more time. We have different of a square. So, hey, you are doing in 5 seconds. 5 seconds, guys. Put into parentheses, boom, boom. Put the square root of this is y, u, plus or minus. Doesn't matter the position plus or minus. Plus first, minus second, or plus second, minus first. It's equivalent algebraically. It's supposed to get this option. I forgot. This is this option. One classical mistake of the student que in the diagnostic test you see, and some students, the majority of students are doing well, but some students no. Suppose que you have y minus 64 squared. And you need to understand the difference between y squared minus 64. This is this. The answer is 5 plus a, 5 minus a. This no, because this is y minus 64 times itself. Y este classical perfect square trinomial is y squared minus 64y minus 64y again plus 128. No, 128 no, it's 64 times 64. No? 64 square, the big number. It's 4,000 something. 1,096. And when you put together this is y squared minus 128. Where come from 128? 64 plus 64. 96. Look at the differences between this answer and this answer. Completely different. Okay, so don't confuse this and this. This scenario is y minus 64 multiplied by itself. It's not. This is different of a square. Okay. Cool. One more. Oh, it's easy. 9, 30, 36. is 9x squared minus 64. Okay, I realize identification. Binomial, nice. Subtraction, nice. Perfect square number 9 and 64, yes. Immediately, I find the square root. This arrow indicates square root. Square root, this is 3x, using the variable, and this is 8. Immediately, I open two parentheses, copy, 3x, 8, plus or minus. Boom, final answer. Super cool. I like trinomial so much because it's easy. It's this. Trinomial piece okay. Binomial, sorry. Trinomial, no. Trinomial is a little bit complicated. It's a complicated part, and you need to practice. Binomial, binomial is easy. Okay, one more. Oh no, I did that, no? A ver. Yeah, no. 37 now. 37. 37 is 9y 4 power minus 49. Maybe this problem brings me a new situation. No, I don't think so. No. It's again different of a square. Doesn't matter. Get the factor is 4. Not necessarily always is 2. Yes, even number is considered a square. And the square root this guy is 3y squared. This is 7. Into parentheses, y squared, 7, plus or minus. And leave it like that, yes, leave it like that, because this is not considered like a difference of a square. The reason is because square root 3 is not perfect, and square root 7 is not perfect, it's decimal. So actually, we can do that, however, it's too complicated. Leave it like that is the option A. Everyone follow me? Okay, we spend the rest of the time in the next page. Try to find the next page. Let's see. Next page. Suppose it's this, no? Is this or not? Oh, yes. Okay. Okay. Okay, 38. Oh, easy. 38 is 81 k squared minus 25 m squared. Oh, it's easy. It's a difference of a square again, because the square root is 9k, and the square root here is 5m. Now this is equivalent. Open two parentheses. 9k, 5m, plus or minus. Boom. I finish. Final answer. End the story. That's it. And we have confusing. They want to write square, and square look like, look, this is crazy. Plus or minus. No, no, this is wrong, because it's like a perfect square. Trinomial. No, not trinomial, binomial. 39, and that's it for today. We continue next time. 39, 39 say 36 x to the 4 power minus 25 t4. Okay, again, t4, no? No, this is 2. A ver, I copy wrong, no? This is not x, it's s. The variable is s. It's s and to the second power. Cool. Okay, again, recognize the difference of a square. The square root this guy and the square root this guy. This is 6s and this is 5t squared. Remember, in the variable, we find the square root T4 is T second. Why? Because you divide 4 divided by 2. And where come from this 2? It's invisible 2 here in the square root, right? See a cubic root, let's see next time. Now ready. Open two parentheses. I copy 6x 5t squared, 5t squared, plus or minus. Boom. You see, yeah. Answer. Never you select this answer. Because this answer comes from maybe the factorization 1 perfect square trinomial. It's a binomial. Do you understand very well? Was clear?
Yes.
Entonces now in next time we continue factorization binomial and we start application of the factorization. So what is the reason that we are doing factorization? What is the utilization of the factorization? Okay. Bueno, guys, I have another class now. Need to leave. Thank you. Bye.
Professor, when is the due date for the test?
I suppose que 23rd.
Oh, next week. Okay, thank you.
Yeah. We have time. This chapter is long. We have time. Pero you start as soon as possible doing the homework, okay?
Okay, thanks.
Bye.